So the coefficient of skewness is a what we call a measure of shape. And here it says it measures the degree of asymmetry of observations around the mean. And so the way that you want to look at this when you're trying to assess the skewness of a distribution, you can think about this as you've developed a histogram and you're trying to see if the bars are more towards the left hand side or if they're more towards the right hand side. And you'll be able to determine if you're dealing with a positive skew or a negative skew type of distribution. And sometimes they're just more all towards the middle, and that would be a symmetrical distribution. And so that's what we mean by if a distribution is skewed or not. Now let's take a look at an example of the purchase orders data set. And I'm going to go ahead and focus on the cost per order column. So I'm going to create a histogram, and I'm going to look at just the histogram, just that visual, and see if it looks more like this type of figure, or maybe this type of figure, or this type of figure, and just make my assessment in terms of if it's a positive skew or negative skew, or it perhaps is a symmetrical type of distribution, and then also compute the actual measure, the numerical measure for this. So I'm going to go to data, and I'm going to be using the data analysis tool tab. So if I go to data and then data analysis, right? So this is an add-on feature, and I am going to select descriptive statistics. No, actually, I want to create a histogram. So I'm going to select that, press OK. And I already have some information plugged in, but I'm just going to delete that, and then I'll just go ahead and I'll start populating these inside here. So the input range is going to be the cost per order. And I did select the label, so I'm going to make sure that's check marked. And then as far as the output range goes, I'm going to go ahead and output that information in the worksheet that I have here called CS. And so I'll select that, move this over, and say plot it somewhere right here. And make sure that this is checkmarked, chart output, so it could actually display the histogram. I'm not going to do the formal method and provide a bin range. I'm just going to let Excel determine that for me. So I'm going to press OK and look at this histogram. So I'll just go ahead and do this, move it, expand it, and kind of compare it to what we have here. So we know that this is related to the cost per order, right? So let me just put cost per order, so I know that what we're looking at. And then I'm not going to worry about fixing up some of these labels and things like that. I just want to focus on how this distribution looks like. So looking at the illustrations that we have here on the left-hand side. So this cost per order distribution looks a lot more like the one on the left, right? A positive skew distribution where we have the majority of our values in terms of the cost per order, or they're all towards the left-hand side, and then it kind of tails off towards the right. So that whole that tailing off towards the right is what we mean by a positive skewed distribution. All right, so just by looking at this histogram, I was able to tell more or less what kind of distribution that we have here, right? So I want to actually get the numerical value that represents the coefficient of skewness. So one way to do this is using the summary statistics. And I'm going to go to data analysis, and then select descriptive statistics, press OK, select the column of interest. So I am going to remove what I had earlier and select the cost per order column. And I'm selecting the label. So that means I need to make sure that that's checkmarked. And then I want the summary statistics. So that has to be checkmarked. And then here, I want to output that information in a worksheet that I have here. So I'm going to put it right underneath the cost per order histogram, and I'm going to press OK. And so I have all of the different types of measures of location, dispersion, and I want to focus on this value right here. So this value, I have 1.66. And so this is the actual coefficient of skewness. And this is another way to determine if you're dealing with a positive skew distribution or a negative skew distribution by looking at this number. So this number happens to be a positive. So then I know it's a positive distribution. Now, if I'm trying to figure out, um, is it highly skewed? Is it moderately skewed? Then I would need to kind of focus my attention on the legend. So I have some notes right here. And here it says if I'm dealing with a negative C-square coefficient of skewness, then it's going to be negatively skewed. And then another way to say it's negatively skewed is by saying that the mean is less than the median. And then here for the positive or positively skewed distribution, then the mean is greater than the median. Now we know that it is positively skewed, so let's go ahead and compare the mean, which is right here, to the median, which is right here. And based off of this legend, this holds true, right? So the mean is greater than the median. And so that's another way to assess if you're dealing with a positive skew distribution. So right now, what we're trying to focus on is it a moderate skewness? Is it or is it strongly skewed? So looking at 1.66 and then this legend that we have here. So for moderate skewness, it says here if the absolute value of the coefficient of skewness is between zero point 0.5 and zero point 0.1. And that's not our case. Our case is actually this next one down, where it says if the absolute value of the coefficient of skewness is greater than 1. So then what we're saying here is that we do have high skewness, or we have a highly skewed distribution, and it happens to be a positive skew distribution. Now, when I say here, if the absolute value of the coefficient of skewness is such and such, right? So what I mean by absolute value is disregard the sign if it's positive or negative and just focus on that number itself. And if it's between these two values, then you'll know if it's moderate or if it's high, right? So that's what I mean, because it's possible that you might run a histogram and do or work on another type of data set, and you happen to have a negative skewness. So just by paying attention to this here, just disregard the sign and focus on the actual value, and you'll be able to determine if it's moderate skew or highly skewed. Right. So now here I have symmetrical, and this is this example that we see here in the middle, where we have if we have a skew or a coefficient of skewness that is close to zero, then we're saying that it's a symmetrical distribution in the sense that the mean, the median, the mode, they're roughly equal to each other. They don't have to be exact, but they're roughly equal to each other. And if they were, then we would have a distribution that looks like this. So you can kind of also think about it in terms of a histogram where the majority of the peaks are towards the middle of the distribution and then kind of tail off equally towards the left and towards the right hand side. Right. So that's what we mean by asymmetrical distribution. And the a lot of things that we're going to be talking about later on when it comes down to probabilities are going to relate to these type of distributions are based off of skewness or if it's a symmetrical distribution. Now, let me go ahead and do another example of, I'll focus on the AP terms column. Now, I'm going to do a histogram. I'm not going to go the formal method by finding the minimum value, the maximum value, and all that. I'm going to let, again, Excel do this for me. So I am going to go to the data analysis. Then I will select histogram, press OK. I'm going to select the input range, which is going to be everything in this column H. And I did select the label, which is the header of that column. And I want to output that information inside same place. I'm going to go ahead and put it, I'll put it right underneath here. So let me see if I can just go down and I'll place it right here. I want a chart output, so that's check marked. I'm going to press OK. And then it brings it over to the top. Let me just drag this down and just kind of just resize this. Now, this is related to the AP terms. Right? So um, I'll just type in for the header so I won't get confused. But AP terms for now. And by just looking at this visual, it's a little bit difficult to determine if this is going to be a skew distribution or even in terms of its magnitude. It's going to be moderate, low, high type of distribution. So looking at a visual just like this is not going to be it's not going to be really easy to determine. So I would do the descriptive statistics, look at the skewness, and then make my assessment that way. But now instead of using the descriptive statistics that I did right here under the data analysis, what I'll do is I'm going to use the function equal sign, and I'm going to select this one right here, skew. So there's skew.p, which stands for population. I'm assuming that the data that I'm working with under the cost per order is a sample. So I just need to go ahead and select all the data inside here and then see what kind of coefficient of skewness that I'll get. So I have the skewness function open still. I'm going to select all of the number values in column H, and then I'll close the parentheses on my keyboard. I'm going to hit enter, and I get this value. Right. So I could also compute the mean and the median and make my assessment if it's a positive or negative skew. But we already know that we have a coefficient of skewness of 0.60. It does fall within the range of 0.5 and 1, so making it moderate. Right. So if it was something like 0.4, 0.3, then it's a very low type of skewness headed towards a more of a symmetrical type of distribution. But let me go ahead and compute the average for the variable that I was focusing on, which is AP terms. And then I'm going to go ahead and do the same thing, but I'm going to do this for, I'm going to do the median, right? So what I'll do is just kind of change some of the syntax here. and that would be the median, right? So kind of close in terms of its value, definitely not a strong type of skewness, and so you would probably want to refer to the CS value if you had it. So another measure of shape is called kurtosis, and this measures the peakness or the flatness of a curve or a histogram. You can see some examples here of how a positive versus a negative kurtosis may look like. And I have some notes here, and these are just a legend. It's a little bit different from the skew, but here it says if the coefficient of kurtosis, the CK right here, if that value is less than zero, then the distribution curve is more flat. But if it's greater than zero, then the distribution curve is more peaked. And what we mean by more peaked, we mean that there's not as much variation uh, in comparison to maybe a different distribution that might be a little bit more flat. So when it comes down to kurtosis, you would want to compare different types of distributions. And so let's go ahead and do just that by focusing on the cost per order data. And so what I'm going to do is I'm going to select the column coming from the data worksheet, but what I'll do is I'm going to put my active cell right here in L1 and hit the equal sign. And I am going to, since this is an equal sign, I'm going to go to the data worksheet and I am going to select this header right here. And you can see on the FX portion that it's referring to the data worksheet and then I have exclamation mark G3. That's G3. So I'm going to hit enter and then it's going to copy or reference the information that's coming from the data worksheet. And I'm just going to drag this down. It's going to drag all of the data that is inside that worksheet. And so once I start seeing zeros, then I know that's probably the last item. And since I am dealing with costs, I'm just going to just work on this format right here and select the dollar sign since we're dealing with money. And then I am going to, what I also want to do is do the same thing, but I'll select this right here, this column where I have the order number, but it also gives me information about the date. So I'll just go ahead and drag that down. And that's pretty much all I need. So what I'm going to be focusing on are two particular portions, and I'm going to develop histograms. I also want to do the kurtosis measurement itself. So I am going to select October data, and then I also want to select the September data. Right? So I'm doing this so I can compare measurements eventually. So I'm just going to put them in different colors, and then I'll refer to them in a bit. Or better yet, you know what? Let me go ahead and do a named range. So that's going to be TP for September, and then these values in bold will be OTT for October. So I can refer to them later. All right. So what I'm going to go ahead and do is I can go ahead and create some histograms and see how they look like. So I'll go to the data portion and then select data analysis, histogram, and in the input range, I'm going to go ahead and do September data. And I'm not going to check mark that since I'm just selecting just numerical values. The output, I'll go ahead and say put that somewhere right here. And I want to chart output. All right, let's see how this will look like. Press OK. So here's a histogram for September. Now what I'll do is I'm going to go ahead and copy this bin range right here. I'm going to paste it because what I want is, since I'm going to do a comparison, I want to make sure that my bands are going to be similar uh, for October. I don't want them to be different. And so I am going to go to data analysis, histogram. Then for the data information, I'm going to select the October data. And for the range, I'm going to select these right here. Put that information right here. Let's see how it looks like. Some data will be hidden. All right, that's fine. And so, yeah, all right, I got what I wanted. Now I can go ahead and delete this since I don't need it anymore. And I'll just pull that back to the right. All right. So now I have two histograms. One's for October. So I believe this one right here is for October. This one right here is for September. All right. And I'm going to resize them and take a look. So, I mean, in terms of skewness, they look very similar to each other. They both look like they are a right right type of skew distribution. So that means it's a positive distribution. Since we're tailing off to the right, things start to decrease off to the right-hand side. And I can validate this by creating descriptive statistics for both of these here. Now, when it comes down to kurtosis, what we're trying to do is we're trying to assess the peak of this. So if we had a line outline for both of these, just by looking at these histograms, it'd be kind of hard to tell which one has a higher peak than the other. Um, but I mean, you can kind of give a guess and say the one on the left just because of the frequencies, right? So that we have right here on the left-hand side. So let me do this. Let me go ahead and now create some descriptive statistics first for these, for both of these months. Now, I am going to do this by selecting the data analysis, descriptive statistics, and I am going to do this first for September. So I'm just putting in the name range instead of having to select the data array. And I want summary statistics, and I wanted to output that information right here. And I'm going to press OK. So that's column 1. So that is representing September. And then I'm going to do the same thing for October. So descriptive stats, press OK, CT for October. And then for the range, right there, press OK. All right, so I'm going to cancel because that's not the correct output range. I want it right here. I'll press OK. All right. Now I got descriptive measures. We can look at the skewness, which we took a look at earlier. They're both they're both positive. This one's slightly more skewed than this one. So September is more skewed than October. But then let's take a look at the kurtosis. So the kurtosis for September is 1.84, and then we have the kurtosis for October is 0.10. So this is closer to 0. Now going back into the legend, and it says here, if the CK, so if the kurtosis coefficient is less than 0, distribution is more flat. So then that means it varies more. If the kurtosis value is greater than 0, which is in fact the case for September, then we're saying that the curve is more peaked. So we're saying that the curve here is more peaked for September, and the kurtosis number is above 0, right? It's above, greater than 0. And so there is also the kurtosis function I could use, even though the descriptive statistics, summary stats took care of that for us. If I hit the equal sign, type in KURT, and then in there, I'll put the specific subset I'm interested in. And I'm going to put SEP for September since I have a named range, and I get the same kurtosis number right here. Same thing for this, OCT, and then I get the kurtosis value for that, right? And so that's how you would approach the kurtosis. So remember, skewness, you're looking to see if the distribution is symmetrical or not, right? If it's left skewed or right skewed. Kurtosis, you're interested in the curve of the distribution. And if it's more peaked, then there's less variation. But if it's a flatter type of curve, then it varies more.